Hello, this is 10.2 basic log properties. We're going to go over some of the properties and a tiny bit of solving at the end. First up, we have definition of a logarithm. So we have log b of x equals c if and only if b to the c equals x. Remember, logs and exponentials, they're inverses of each other. We can use that to solve and make sure our logs are following those properties. Next, we have natural log, that's an ln, equals natural log of x equals c if and only if e to the c equals x. Just remember, ln is the same as log base e. And we also have our basic log without a base is always log base 10. All right. Let's do some examples. We're going to switch between the two forms. First up, we're going to go from log to exponential. This first one, 4 to the third equals 64. And you're done. Simple. Just changing forms between the two. Remember, base, this is your x, and c is your exponent. All right, next one. So our base, 5 to the negative 2 equals 1 over 25. This is an important one to remember. On your assignment, you have negatives or you have fractions. You want to make sure that you understand when you have a negative exponent, it is going to make it into a fraction. It's going to bring that base down to the denominator, and you put 1 on the top in place of your fraction. Another thing to remember with fractions too, if you have a square root, that's going to be the same as, let's put this as like x. So that would be the same as x to the 1/2. Just be careful when you have a fraction by itself, it's going to be a negative exponent. But if you have a fraction in the exponent spot, it's going to be a radical. So make sure you're good on that. All right. Next one, 65 to the 0 power equals 1. That's our 0 power property. Anything to the 0 power is always 1. And then it works for anything. So whether it be shapes, variables, numbers, anything works in that same switching property. So this would be triangle to the star power equals happy face. Okay. It works for all of it. All right, now we're going in reverse. We're going to go from exponential to log form. All right, so we have log base 3 of 81 equals 4. Remember, it equals the exponent. So you're going to trade places and set that up. All right, next one, log base 10 of 1 over 100 equals negative 2. And then you can write it, since it is that base of 10, you can write it without a base. And that would be the more accurate answer for those ones. So just remember, base 10 is your empty log. All right, next, log base 6 of 6 equals 1. That's one of our properties that we'll go over when the base and the inside are the same. It equals 1. All right, and then just like the smiley face one, this is just with variables, so it's just switching those to the correct places. And there you go. Just make sure you're switching those in the correct order and the things go where they need to go. Here are our basic properties of logarithms, where b has to be greater than 0, not equal to 1, so this is your bases, and then the inside x has to be greater than 0. Remember when we did graphing, we have that hard asymptote, that vertical asymptote where we can't cross over. We have to make sure we do that for when we do it as just equations instead of the graph. All right, first step, we have log base b of 1 equal to 0. So anytime we have that 1 inside that log, it's going to equal 0. Because if we switch it to b to the 0, that's going to equal 1. That's why that property works. Next one, b log base b of b, it equals 1. So essentially that's just crossing those out to be just a 1. All right, we have log base b of b to the c, and it's just going to equal c. So it's going to cancel those b's out and leave us with just that exponent. Same as if we have b raised to the log b. So those bases have to be the same in order to cancel it out. So be careful. And then it's just going to equal the inside of whatever that log is. And then just remember, natural log is log base e, and then log base 10 is just your log without a base. That will help you remember. You're like, okay, it doesn't have a base. What do I do? Well, it's going to be a base of 10. All right, well, let's do that. Our first example has that exact thing. So no base, that means it's a base of 10. So log base 10 of 10 cancels each other out, and we're just equal to that exponent. All right, next one, we have that e to the natural log. That would be an e to the log base e of 6. So now the bases are the same, cancel it out, and we're left with 6 as our answer. Next one, we have log base 3 of 1. Well, they don't match, but remember that property where we have a 1 on the inside, it's going to equal 0. All right, next one, log 50 of 50 cancels each other out, and we have a 1 left over. So remember, kind of like when you have a fraction, you have like 50 over 50, that's going to be a 1 because it's going to equal that same thing, top and bottom. You're going to have that 1 left over. Anytime you don't have something, remember you always have that little 1 left over. All right, you might have to do some solving on these ones to match the bases. So when we do that, you're going to look at your base of your log and see, can I change that inside to be that same base? For example, e, we want to see, can we turn 32 into a base of 2? So 32 base of 2 to what power? In your calculators, you can check to see, can I get 32 by doing 2 to some power? So 2 squared, and if you know your 2's, you might already know the answer already, but you can always check to make sure that you're doing those correctly. I just kept going just to show you. You can keep going until you find the answer. So we got 2 to the 5th. That's going to be our 32. So now we can sub it. So log base 2, 2 to the 5th power. Those cancel, and we're left with 5 as our answer. All right, same with this one. Remember that fraction property. We want to change it into that negative exponent. So log base 4 of 64 to the negative 1. Anytime you have those fractions, you want to change it, or anytime you have a radical, you want to change it to an exponent just to make things easier for yourself. All right, same thing like we did with a 32. We want to see, can we turn 64 into a base of 4? So you check again, or if you already know the answer, because you might know your 4's as well. So 4 squared, not what we're looking for, but 4 to the 3rd is. So always just check, because it could be a different one, like a 7 or a 9 or a 12 when it gets into those higher exponents that you might not know the answers. There's one on the assignment where it's 3 to the 5th power, and you might not know those exactly. So just be wary of those, and always check your calculator. You have that resource, so use it. All right, 4 to the 3rd. So that's going to be log base 4 of 4 to the 3rd. And then if we have an exponent that's already there, you're going to multiply it. So log It's that power to a power property. Base 4 of 4 to the negative 3. Now, those 4's cancel each other out, and we're left with just that negative 3. All right. Principle of exponential equality. For any real number where b is not equal to 1, 0, or 1, we have the base b of x sub 1 equals base of b, x sub 2 is equivalent to the x sub 1, x sub 2. Basically, in more simple terms, if your bases are the same, your exponents are going to be equal to each other. So you can set them equal to each other and solve for your variable. So let's check it out. If you start out with a log, that means you need to change it to exponential form in order to get it to see if your bases are going to be the same. All right, we have 2 to the x equals 8. We want to see, can we turn 8 into a base of 2? So 8 equals 2 to the what power? Well, 2 squared is 4. If we do it again, 2 to the third, that's going to be 8. And you can check it in your calculator. Or remember from the list that you did before for 2 to the 5th, you can see that that's in your list of answers. All right, we have 2 to the x equals 2 to the third. Bases are the same. So then we can set up our exponents to be equal to each other. Then you check, do I need to solve for anything else? Well, x is by itself and we have a number on the other side. We are done. All right, next one. 7 squared equals x. This time we don't have bases that we're matching, but we just do that operation that it gives us instead. Because this is just a number on that side. We don't have a variable anymore on that side. 7 squared is 49, and the x is alone on that side. So we would be done. If you sub that back in, so you have log 7, 49 equals 2. Remember, 49 is 7 squared, so it cancels out where we would be 2 equals 2. So it checks out. So if you want to check your answers that way, you can, just to make sure that you set them up correctly. All right, next one, x to the third equals 125. Same thing, we don't have a base that we're matching. So how would we get rid of an exponent? Well, we take the root of it. But it's a different root than just a square root, so we have to be that root of 3. So then those cancel each other out, and we take the cube root of that other side. If you don't remember that that's going to be 5, or when you're taking the cube root of any number and you don't know the answer, trusty calculator comes into play. You're going to go to math and down to option 4, and then you get your third root. If it's a different root, you have to do that number. So say you're doing the 4th root. So 4, math, 5, and that changes the root to a different number. All right. So that is going to be 5. All right. Next one. We have 27 equal to 9x plus 1. We don't have a log, so we're not changing form. So next you check, can I turn my numbers into the same bases? You check, do they have numbers in common? 27 and 9. Well, they each have a 9 in common, but 9 to the first is 9. 9 squared is 81, so it can't be a base of 9. So then we take it down. They have a 3 in common. Can we do 3 to a power to get 27 or 9? Which we can. 3 squared is going to be 9. 3 to the third is going to be 27. So we would do 3 to the third equals 3 squared, because that would be 3 to the third here and 3 squared. And then this had an exponent already. So remember, we need to multiply that. 3 to the third equals 3 now to the 2x plus 2. And then now the bases are the same, so we can set those equal to each other. And then we solve. Subtract 2. 1 equals 2x. And then we divide by 2. X equals 1/2. Order of operations. Solving in the correct order, getting rid of things. Remember, if it's multiplying, you divide. If it's dividing, you multiply. If it's adding, we subtract. You do those reverse operations. All right, next one and our last one. We have 4 squared equals 3x minus 2. No bases to deal with. And 4 squared is just a number on that side. It doesn't have an x with it. So we can just do that operation before we solve. So 16 equals 3x minus 2. Now we can solve. We add 2. We get 18 equals 3x. Timesing, we want to get rid of by doing divide. And we get x equals 6. Just remember, you're doing reverse order of operations to solve. Make sure you do those opposite operations. And then if you have radicals, you change them into fractions. For example, if you had the 4th root of, let's say 75, that's going to be 75 to the 1/4. Okay. If you had 36 to the 1/3, that would be the same as cube root of 36. And then if you have an empty root, so let's say you have the square root of 5, that's going to be 5 to the 1/2. Okay, just remember those properties of exponents where you change forms back in Math 2, maybe in Math 1, maybe in 7th and 8th grade when you did exponent properties. Just remember those when you're doing your assignment. And then just remember, if you have a fraction, so let's say you have 1/81, that's going to be 81 to the -1. Okay, so you're just changing it to a negative. Or if it's negative, you change it into a fraction. All right, if you have any questions, please let me know. Otherwise, you are working on your assignment.